Are you ready to witness a game changer in the skies? Imagine a fighter jet that's not just one, but two steps ahead of the present. In today's thrilling episode, we're taking you on an unprecedented journey to test the most advanced, most secretive, and undoubtedly the most extraordinary aircraft ever built, the seventh-generation fighter jet. The world is changing quickly in the high-stakes race for military aircraft. Russia and China are working hard to make engines strong enough for their fifth-generation jets, but the United States, Japan, Great Britain, Germany, and France are already one step ahead. Each of these countries is working hard to make the most advanced sixth-generation planes possible, with the U.S. leading the way. The United States has already made a big step forward in a very secretive setting. They were able to safely test fly a prototype fighter, which is the first of the advanced sixth-generation aircraft. The seventh-generation fighter is the next big thing, and even though full production hasn't started yet, the wheels are already turning. The American Next-Generation Air Dominance (NGAD) effort is at the center of this big step forward. This project is moving through the complicated stages of development and is getting closer to a stage called Initial Operational Capability (IOC). Once the facilities for making important parts are set up and an assembly line is made, this step will begin. However, what really stands out is the huge technological step forward that has already been made in the creation of these future fighters. This major step forward is mainly due to the innovative use of artificial intelligence, AI, in almost every part of aircraft development. AI is at the center of everything from coming up with ideas and defining combat roles to simulating real-life air combat situations. This new way of doing things has greatly sped up the creation process, allowing up to 10 times faster production of new planes than it took to make older ones like the F-22 or F-35. Even more interesting is the fact that this could be the first time in U.S. military history that growth orders are not made by human generals, but by an AI neural network. This change shows a deep understanding that AI may have a better grasp on the future of war and the qualities that fighter jets need to have. AI can model the plane's structure and engine and make predictions about how it will perform in the air, in addition to handling strategic and tactical issues. AI's ability to model reality also lets pilots test and experience these futuristic planes digitally. But maybe the most important thing is AI's part in taking into account the current state of technology, such as the availability of new alloys or materials. In the NGAD program, people's main job is now to feed different kinds of data to the neural network. High-level military officials now mostly look at the results that AI gives them. If you want to fully understand how revolutionary sixth-generation fighter jets are, you need to know the 5 main things that make them different from their predecessors. These features aren't just small improvements. They're a big step forward in aerial combat technology that will usher in a new era in military flight. The first feature that stands out is the ability to use laser guns. There are high-energy laser systems out there now, but they aren't as powerful as they could be. Today's fighter jets get most of their firepower from a variety of weapons, some of which are hypersonic. However, sixth-generation jets are being built with the ability to add laser weapons in the future when the technology gets better. Because they were designed with the future in mind, these jets will not only keep up with technological progress, but they will also lead the way into the future. The second revolutionary feature is the variable cycle motor, which was created by Lockheed and Aerojet Rocketdyne and is a marvel of modern engineering. When the speed is less than Mach 3, this engine works as a turbojet, but when it needs to go faster than sound, it changes smoothly to ramjet mode. This two-engine system has the same air intake and exhaust nozzles, which is a smart design that keeps the plane's aerodynamic efficiency even when it's going very fast. Using stealth technology to build planes has become an art form that combines form, function, and high-tech materials. The airframe's form and profile, along with special coatings, are the main things that make it harder for radar to see. But it's not just the way the plane looks. The tech inside also plays a big role in its stealthiness, blocking low-frequency radars that can find stealth planes. The modular form of these cutting-edge fighters is another thing that makes them stand out. Imagine a plane that can change how it looks to fit the needs of different combat tasks. This flexibility is made possible by a system of equipment blocks that can be switched out and in as needed. Because of this, the fighter can be customized to fit a variety of tasks, making it more useful in a wide range of combat situations. Unmanned control is the fifth part, which may be the future. Without a driver, these fighters can reach speeds faster than sound and make moves that are too hard for humans to handle, moves that would put a pilot through extreme G-forces. The lack of a seat also makes room for important systems like cooling units, which are needed to deal with the high temperatures that come with these speeds. The seventh generation brings about changes that make these traits even better and meet even higher standards. These fighters are ready to take over near-space environments because they can fly at heights and speeds that are beyond the reach of even the most powerful air defense systems, such as Russia's S-500. There is a chance that the shape of a seventh-generation fighter will make you think of the T-65 X-Wing space fighters from Star Wars, but with a twist. Even though these new planes are designed to fly in the atmosphere, they can sometimes go into near space. The structure of these jets needs to be strong enough to handle huge amounts of heat and mechanical force. Hypersonic speed needs a certain form for aerodynamics. Most likely, the body will be made of heat-resistant materials such as titanium, steel alloys, ceramics, and composites. A swept wing and large air intakes are necessary, and the payload is built into the aerodynamic body to keep it from getting too hot at hypersonic speeds. With this kind of design, the seventh-generation fighter isn't just an airplane. It's a lightning-fast strike machine that can hit important targets at speeds that have never been seen before. Imagine being able to cross the Atlantic Ocean in just over an hour. That's the kind of game-changing power these futuristic weapons have. There will be no noticeable difference in the flight characteristics of the seventh-generation fighter jet as it moves between subsonic, supersonic, and hypersonic speeds. Imagine a marvel that connects the famous SR-71 Blackbird to the cutting-edge Lockheed SR-72. The combined cycle power plant, which was created by Lockheed and Aerojet Rocketdyne and was first thought of for the SR-72, is a big reason for this flexibility. The top speed of sound waves is too fast for regular turbojet engines to reach. On the other hand, using only a ramjet engine isn't an option either because it needs to be sped up at first. Lockheed Martin and Aerojet Rocketdyne have come up with a ramjet engine that can take the fighter into hypersonic flight to solve this problem. Because of how dangerous it is to fly at those speeds, the smart fighter will be controlled from afar and will be able to operate on its own in an unmanned mode. This is because radio contact with ground operators is very difficult during hypersonic flight. An important part of the seventh-generation fighter system will be connected to Link 16, a network that connects satellites, warships, submarines, planes, drones, and weapons for exchanging tactical data. This connectivity makes it possible for different units to work together smoothly at both the tactical and operational levels. As for weapons, the usual equipment won't work in areas close to space. The future belongs to energy weapons, especially lasers that are very strong and can disable key ground targets and even enemy satellites. Hypersonic missiles are also being thought about. The fighter could be used as a launch base for these missiles, which would make them smaller and cheaper. There is no question that this high-tech fighter will cost a lot. It could be several $100 million per unit, which is a price that a superpower like the US can afford. Putting money into such cutting-edge military technology isn't just a way to stay ahead. It's also a way to keep possible attackers away. When you think about US history, it's interesting to note that the Lockheed Martin F-22 Raptor, which went into service in 2005, was the first fifth-generation fighter to be made in the country. This is even more proof of how strong the American military is. The Air Force, Navy, and Marine Corps all use different types of fifth-generation jets, such as the F-35 Lightning II.